So welcome back. I hope your Thanksgiving was fun. I hope you enjoyed your week off. I really enjoyed my week off. Okay, so we're getting back into factoring. We did this a little bit before you left, so that's what we're working on again today. Students will be able to factor trinomials with the real factors in the form of ax squared plus bx plus c. So factoring, remember that's when we have a full trinomial and we break it into two different parts, okay? They give us a polynomial and we're breaking it into two different parts. We're doing the opposite of multiplying, okay? Factors are what make up something. So we have 6x. 2 times 3 will give you 6 and then the x. So it's just breaking apart something into pieces. Those are the factors. Okay, greatest common factor is just that. It's the biggest factor they have in common. The greatest common factor is the biggest factor they have in common. The sum of perfect squares is when it's x squared plus 4. Both of these are perfect squares, okay? So a binomial in which the terms are added perfect squares, okay? So the sum of perfect squares. The difference of perfect squares is when you're subtracting two perfect squares, okay? So let's look at your worksheet. I'm going to do a couple examples and then you'll do the rest on your own. So we're going to look here at number 1. What's the first thing we need to look for? Who remembers? The greatest common factor. Do they all have something in common? No, they don't all share a greatest common factor. Okay, so the next thing we have to do is the rainbow. Remember? Okay, so 1 times 16 is what? 16. Tell me, what are the factors of 16? 1 times 16, 2 times 8, 4 times 4. Okay, 1 and 16 add up to what? 17. 8 and 2 add up to what? 10. And 4 and 4? 8. Which number do we want? 10, because of this right here. Okay, so we want these. Now, we'll make our box. What goes here? The x squared. And then what goes here? 16. So what goes in these two boxes? The 2 and the 8, followed by an x, right? So 2x and 8x. What do we do from this point? Yeah, we find out what they have in common. It's like a puzzle, so it's like Sudoku or some other puzzle like that. You have to figure out what they have in common. So looking at this row, what do both of these have in common? They both have an x. What do both of these have in common? They both have an x. So from here, you can just do x times what gives you 2x? 2. And then x times what gives you 8x? 8. Then check over your work and be sure you did it right. X times x is x squared. X times 2 is 2x. X times 8 is 8x. 8 times 2 is 16. So what are our factors? X plus 8 and x plus 2. Okay, so that's number 1. So number 2, what's our first step that we're going to do? What's the first thing we look for? Greatest common factor. Do they both have something in common? What? An a, so we'll pull that out. So if we take an a out of a squared, what's left? Let's do it this way. So a squared, 6a, we took out an a. So what goes up here? A times what gives you a squared? A. A times what gives you 6a? So what goes inside here? A plus 6. Okay, double check your work. A times a is a squared. A times 6 is 6a. Okay. So now let's look at number 3. Number 3. This is a difference of two squares, right? Is 36 a perfect square? Yes. Is 49 a perfect square? Yes. So 36 is the perfect square of what? What makes 36? What times what gives you 36? 6. What times what gives you 49? 7. Okay? So here's how you do the difference of two squares. It's an easy little cheat. Okay? You can do all the work that we normally do, or you can do this. So 6, and what? How do you, if you take the square root of r squared, what does that give you? Just r. Okay? So here's how you do the difference of perfect squares. You ready? 6r plus 7, 6r minus 7. Do you see what we did there? You find what the perfect squares are, and you add a plus and a minus. That's it. Okay? You can work it out the long way if you want to. That's fine, but it gives you like crazy big numbers. If you were to check this work in the box, you'll figure out that it gives you the exact same thing. Okay? So that's a little cheat for you. Difference of two squares, it's always the perfect square plus 7, or plus perfect square minus 7, or the perfect square. All right, so now let's look at number 5. Number 5 is written a little different. What do you think we should do? Yeah, I would rewrite it into standard form. So 4k squared goes first, and then 44k, and then 121. Okay? Now, do they all have something in common? No, they do not. So what do we need to do next? The rainbow. Doing the rainbow, what does that give you? 4 times 121 is what? 484. Okay, so we need to come up with the factors of 484. Is that on your factoring sheet? No, so we have to figure it out. So we know 1 times 484 is a factor. Can you divide 484 by 2? 2 and what? 200 and what? 42, okay? So type in 484 divided by 3. Did that work? No. 484 divided by 4? 121. 484 divided by 5? 484 divided by 6? No. 484 divided by 7? 484 divided by 8? No. 484 by 9? No. 484 divided by 10? 484 divided by 11? 11 and 44. Okay? 484 divided by 12? Did that work? 484 divided by 13? That work? 484 divided by 14? 484 divided by 15? 484 divided by 16? 484 divided by 17? 484 divided by 18? 484 divided by 19? 484 divided by 20? 484 divided by 21? 484 divided by 22? 22. Okay, so that's going to be it because these two numbers are the same. So if we add them all up, I'm just going to add up the bottom one. It does give us 44, which is what we're looking for. Okay? So we'll make our box. 4k squared goes here, and 121 goes here. What goes into this box? 22k, right? Because of the 22 here. And what goes into this box? 22k. Okay, those two. So, what do these two have in common? They both have a k. What else can they both be divided by? 2. Okay. What about these two? It's the same thing, right? So 2k. So now let's ask ourselves, 2k times what will give you 22k? 2k times what will give you 22k? 11. And it's going to be the same thing here, right, because they're the same. So double check your work. 2k times 2k is 4k squared. 2k times 11, 22k. 2k times 11, 22k. 11 times 11 is 121. So what are our factors? 2k plus 11 and 2k plus 11. Okay, I will also accept 2k plus 11 squared, because it's the same thing, right? Okay, so either one of those would work. Now let's look at number 7. Number 7. I'm going over number 7 because a lot of you get confused by stuff like number 7. You miss certain things. So, looking at just the numbers, what can you divide them both by? What's their greatest common factor? Look on your factoring chart. See what 20 and 12, their greatest common factor. What is it? What's their greatest common factor? Nope, bigger. 4. So you can pull a 4 out of both of those. 4 times what will give you 20? 5. And then we have our a to the 4th, b to the 7th, plus 4 times what gives you 12? 3. And then we have a to the 9th and b. Okay? Huh? 4. Okay. So now looking at this, what else do these have in common? They both have at least 4 a's, right? So we'll take out 4 a's. So we have 5. There's no more a's here because they're all out here. B to the 7th. Plus 3, a to the 9th. What's 9 minus 4? So we have a to the 5th. Okay, because we took out 4 a's from both of those. We just sucked them out. Okay, what else do they both have in common? They have 1b. Both of them have 1b, so we have 5. If we take out 1b from here, how many do we have left? 6 plus 3, a to the 5th, and we took out 1b here, so we have none. Take it step by step like that if you need to. Okay, so now I'm going to talk you through number 10, but I'm not going to do it for you because I want you to do it yourself. Okay, so looking at number 10, they give you the area of a square, right? So we have the area of a square. It's 9x squared plus 24x plus 16. Okay, how do you find area? Length times width, right? Okay. So it's going to be this times this, correct? How can we find these two things? By factoring this, right? Factoring will give you the two sides. So you're going to factor 9x squared plus 24x plus 16. I forgot to put the x here. Okay, you're going to factor that. Then, once you have the sides, how are you going to find the perimeter? How do you find the perimeter of a square? You add all the sides. So once you find the factors, you're going to add the factor, this one, plus this one, plus this one again, right, because it comes down here. And then plus this one across here. Okay? So that's how you're going to find the perimeter. Then you'll combine like terms, and it'll be okay. Any questions on this? All right, so you have the rest of the period. Finish up this paper. Check your answers with me. When you're finished, you work on Alex. Let me know if you have any questions.